Okay, so today we are going to solve a problem which appears in the Malaysian APMO CST, and it is placed in problem 3. So what is APMO? It stands for the Asian Pacific Mathematical Olympiad, which means most of the countries which are in the places such as North America, part of South America, and the Southeast Asia will attend these mathematical Olympiad. So this problem appears in the selection test of Team Malaysia. So since it can be placed in problem 3, that means it is a hard problem. So actually it is true. This problem is very difficult to deal with. Let's take a look at the problem first. We can know that A, D, B, and CF are the three altitudes of the triangle ABC, and H is the intersection of these 3 segments. Actually, H is the orthocenter of the triangle ABC, and from the next sentence we can know that AX bisects the angle, the interior angle BAC, and AY bisects the exterior angle BAC, right? So we draw the 2 second circles of triangle BHX and CHY, and let them meet again at ZAC, and where M is the midpoint of BC. So we can try to prove that the angle H stack M is equal to 90 degrees. So thinking about 90 degrees, how will you deal with it? Or how will you do to try to prove such a 90-degree angle? My original thought is this one. If we make this line MZAC, let it make the intersection like P and Q, right? So we try to prove that the PH or HQ is the diameter of one of the 2 circles, or we try to prove that the angle PBH equals to 90 degrees, or the angle QYH equals to 90 degrees, so that we can make it. But how can you make it? How can you prove that? That is the problem. So actually it is not easy to go from this way. So how can we change our mind, or from other things? We can start from other things. Maybe from the point M, or from the angular bisectors. How can we deal with this problem? Or the point H, because it's a special point in the triangle ABC. So how can you deal with it? Actually here, from my point of view, the point M is quite a useful point here. Why do I say this? If you consider a triangle here with its midpoint, how can you deal with this midpoint? Some of you might say, we can construct another midpoint on the other side, so that these 2 midpoints make a midline of this triangle. Actually it is right, but is it good to make another midpoint in the triangles? Actually it is not proper. Why? because there are enough points in the interior of the triangle, and it is complicated enough. So if you add another line or another point, how can you deal with, or it is difficult for you to find out the associations between these points, among these points. So what are the other thoughts of dealing with this one? What are the other solutions? My answer is to extend these segments. Such that these two segments are equal. So what is this one? It is a parallelogram, right? What can a parallelogram bring? Of course, parallel lines. So what can we learn if we have parallelograms? Then we can find parallel lines, and from parallel lines if we can prove the other angles which equal to 90 degrees, so according to the parallel lines, we can make it to prove the angle h dash m equals to 90 degrees. So let's try. So I will use another picture that I have drawn it in advance. It is like this. Since like if we extend, let me write it down. Extend AM to G such that MA equals to MG. So what can we have? Place it here. What can we have? We can have a parallelogram here. Which is, where is it? AB GC, right? And then what can we have? We can have AB parallel to GC. So I would like to introduce some of the points. For example, if we connect the points BG, let the segment BG intersect the circle BHX at another point P, and if we extend the segment GC and let it intersect at the circle CHY at another point Q. So we have got these 2 points, right? These 2 points P and Q. So what can you observe from this diagram? From your observation, we might think that here are 3 parallel lines. Maybe it's right. AB it's not. Just that. AB, PX, and CG. Right? They look parallel. So we try to prove that. To prove that these 3 lines are parallel. So we only have to prove one of them. For example, PX parallel to GQ, right? So how can we get it? Since we have AB parallel to GC. Then I use the blue pen. Since we know AB is parallel to GC, so the angle AFC equals to angle FCG equals to 90 degrees, right? Because of the perpendicular lines here and here. What would that bring about? And that means the angle, since the angle FCG equals to the angle HYQ, so the angle HYQ is also a right angle. Angle HYQ. So what can we get from that? Obviously, we have another perpendicular line. It is here. Plus angle BEC equals to 90 degrees equals to angle BYQ, which is HYQ is just BYQ. So EC is parallel to YQ. So we can get BG parallel to AC and parallel to YQ. Is it? So what can we have then? So then we can have the angle PBH equals to 90 degrees. Why? Because of the parallel lines, right? Parallel lines. And then how can we prove that? The the parallel lines like AB, PX, and GQ. So we can try another pair, or if we study this angle, which is BPX, it is here. We know that the angle BPX equals to the angle BHX, right? Because of they are on the same circle, and equals to the angle CHE. Is it? It is obvious. Equals to 90 degrees minus the angle ACX. Here, ACX is here. That's obvious. And equals to 90 degrees minus angle ABY. It is also here because the angles BFC and BEC are all equal to 90 degrees. Then we have the 4 points BCEF are consecutive, so we can have these two angles FBE and FCE equal. So after that we have equals to this and equals to angle BA. Right? We have another perpendicular line which is BE. Yeah, so it's here. And then equals to 180 degrees minus angle ABP. Yeah, it is here. Oh, I use another color. ABP is here. Why we can infer that angle BAE plus angle ABP equal to 180 degrees? That is because we have AC parallel to BG, right? So what can we have after knowing that the angle BPX plus angle ABP equal to 180 degrees? That is parallel, right? So we can easily know that AB is parallel to PX. Is that true? So, and then we can know that AB is parallel to PX and parallel to GQ or GC, right? So we have successfully proved our guess. So I use another diagram. After having this, what are the right angles we have? We have this one. We have this one. And we have this one. Yeah, since these, like the points BP, ZAC, H, or H, ZAC, QY are concycling, how can we get that the angle HCM equals to HZAC P or HZAC we have to prove that MZAC Q are collinear, right? That is required. So what we want to prove that is we want to prove that the points P, M, ZAC, and Q are collinear. Once we got this, then the problem is solved. So the most difficult part is also here. So how can we prove that? That is the problem. If we want to prove that the 4 points are collinear, we have to prove that like 3 points and are collinear, and the other 3 points are collinear, so that we can get this. So we can start from the easier ones. Maybe it is pizza Q. First, pizza Q collinear. How can we make it? We can use a method. That is, extend PZAC and let PZAC intersect the circle CHY at the point Q, or not Q, it is the point R. So after having this point R, what can we have? We know that we have the angle XPZ equals to XPZ, it is here, and equals to this angle, equals to angle ZAC HC, and equals to the angle the QC, which means that PX is parallel to GR. Oh no, I wrote it wrong. That is Zag RC, right? Zag RC. Because it's just a supposed point. And that, so that we can know that since GR is parallel to PX and GQ is also parallel to PX, and also how can I say, R and Q, these 2 points all lie on the circle CHY, so that we can know that no, the points are equals to Q, so that we can know that the first part is proved. And next, we try to prove that PMQ collinear. Use another graph, a new graph, because here it is a little bit difficult. We have to use the Mendelow's theorem, also actually the converse of it. So we might use converse of Mendelow's theorem. We might think of the triangle BGC, which is cut by the line PMQ. So we can calculate these things. BM over MC equals to times CQ over QG and times GP over PB. Since M is the midpoint, so BM over MC, it is 1. And CQ over QG, what can we get from it? CQ over QG, since we have YQ parallel to EC parallel to BG, like these 3 segments are parallel, we can know that CQ over QG actually it equals to EY over YB, right? And in the same way, GP over PB, it is because these 3 parallel lines here and here. So GP over PB equals to CX over XF. Oh no, I wrote it wrong. It is FX over XC. FX over let me check if I'm wrong. Yeah, it is. I'm wrong. The first one is correct, yes. So the one is eliminated. So EY, what does EY mean? Actually, we can study this angle. This angle. Yeah. Maybe we noted it as angle 1. Angle 1 equals to 90 degrees minus angle CAY. And we know that AX and AY are all the angular bisectors of the interior and exterior angle BAC. So we can know that it is a right angle, right? So it equals to 90 degrees minus 90 degrees minus angle XAC. So it equals to angle XAC, which is half of angle A. So what can we get from that? Since we know that, we can have so EY equals to AY times cosine half of angle A over YB, and times CX. XF is in the same way. It is AX times sine half angle A. So we finally get this thing, that is CX over AX times AX over YB times cosine this one and over sine half of angle A. So how can we convert CX over AX? That is the problem right now. CX over AX. We have proved that the angle 1 equals to half of angle A. So it also equals to this one, angle 2, right? If we denote it as angle 2, so equals to angle 2. And also from the four points consecutively. From the 4 points B, F, E, and C consecutively, what can we know? We can know that these two pointed angles are equal. So we can easily know that the triangles BAY is similar to the triangle CXA. So we can get what we want, that is CX over AX. So we can know that AB over CX equals to AY over XY. Oh, I wrote it wrong. It is XA, right? CXA AY over XA. So we might find that CX over XA, what is it? It is AB over AY, right? AB over AY times AY over YB times cosine half of angle A and times sine half of angle A. So we can eliminate these two. So it equals to AY over YB. AB over YB times this one. So after having this, according to that, which is AB over YB, AB is this line, this segment here, AB, and YB is here. Where is it? YB is here. What can we use? We can use this law of sines, right? So AP over YB means sine angle 1 over sine angle, or maybe we call it angle 3, times cosine half of angle A times sine half of angle A. Angle 1 is equal to angle A, half of angle A. So these two are just similar. And also we note that angle 3, did I write it wrong? Oh no, angle 3 equals to 90 degrees minus angle A. Right. So, did I write it wrong? BAY. Oh, I'm too sorry. It's not here. Angle 3. I'm too careless. It is angle, not AY here. Oh, so it is here. BY. Marked it wrong. So it equals to BAY. So the angle BAY equals to 100 degrees minus 90 degrees minus half of angle A. So we can know that sine angle BAY equals to cosine half of angle A. It is obvious to prove that. So that equals to 1. So according to the converse of the Menelaus theorem, what can we know? We can know that the 3 points P and Q are collinear, and at this one over, we can know that P and ZQ are collinear. So after that, it is very easy to prove that the angle HZM equals to 90 degrees. So that's the end of the proof. Thank you for watching.